Okay, good morning. So yesterday we started with the different the types of the projection methods and orthogonal projection in detail we have discussed, and four quadrant system and a few examples of projection points also we have discussed. So few more examples so we'll discuss in this class. So coming to the next example which I have taken. A point is 35 millimeter below HP, 20 millimeter behind VP, and 25 millimeter from RPP. Draw its projection and name the side view as given. So let me take the first the sentence. A point P is 35 millimeter below HP and 20 millimeter behind VP as given. Which quadrant it comes? Below HP and behind VP. So it comes under third quadrant. It is below HP and behind VP. So that means after drawing a XY line, so you can write the HP and VP position. So for the third quadrant, HP will come above XY line and VP will come below XY line, and it is exactly the opposite to that of the first quadrant. So you can, after drawing XY line, you can fix your HP as well as VP also. So after this, so first sentence, let me read. So what is the first sentence? Yes, a point is 35 millimeter below HP. Always the above HP and below HP information will give you the front view. In front of VP and behind VP information will give you a top view. So it means he has given a point is 35 millimeter below HP, and while drawing the projection, below HP means below XY line, above HP means above XY line. So that means you take a 35 millimeter below HP means below XY line, and draw an horizontal projector line anywhere. So you locate one point on that 35 millimeter line and call it as the A dash because it's a front view. Okay. So after this, the front view is completed for this. Next, the point, let me read. He says 20 millimeter behind VP. So behind VP, it is the top view information. And regarding behind VP, it is above XY line we should draw. In front of VP, we should draw below XY line. That means so you take 20 millimeter behind VP, you take 20 millimeter above XY line, draw an horizontal projector line, and then already I have located a point A dash, that is front view. You draw a vertical projector from here till it meets the horizontal projector of 20 millimeter line. Okay, so wherever it meets, you call that as the point, highlight there, and call this as the A. This itself is your the top view. So with this, both front view and top view is completed, and we need to concentrate now on the side view. So next information what he has given. A point is 25 millimeter from RPP. RPP means right side, right profile plane. That means RPP is given from the point wherever you are drawn the front view and top view, right side, the distance you have to take. So you take, so this is your front view and top view. You take 25 millimeter right side distance, 25 millimeter from RPP, and draw a perpendicular line to XY line, and you call this as the one more reference line, that is X1 Y1. The intersection between your XY line and X1 Y1 line, so this is the origin, you call it as the O. And then so wherever you are drawing the side view, there you have to write the RPP or left PP, LPP. So this is your front view. Always the side view you are going to get either left or right side of your the front view only. So that means you call so this particular portion as the RPP. And where to draw 45-degree line? Wherever the top view you are getting, on that side you need to draw the 45 degree. And also in the last class we have discussed why the 45-degree line has to be drawn. To transfer the same distance from the top view to side view, we need to draw this 45-degree line. So from this origin, let me draw a 45-degree line like this. After drawing a 45-degree line, you take a top view, that is A. From A, you draw the horizontal projector like this till it meets the 45-degree line. Okay. Similarly, once it meets the 45-degree line, you draw a vertical projector downwards like this. The arrow also I've written here. That arrow mark will give you, okay, from where to where you are drawing the projector line. Now similarly, from front view A dash, you draw the horizontal projector line like this. So wherever the horizontal projector of your front view and vertical projector of your top view meets, you call that as the A double dash. So this itself is your side view. And name the side view as which side view it is, because it's a third the quadrant. So the point lies in third quadrant. For the third quadrant, RPP which you will going to get third and second quadrant. So right profile plane you will going to get right view only, left profile plane you will going to get the left view. Correct. So that means, so the side view, name the side view as asked. So this intersection point you call that as the A dash, the side view, and the name the side view in this is right side view because it's a third quadrant example. Okay, both for the third and second quadrant, RPP right view only you will get, LPP left view only you will going to get, whereas for the first and fourth quadrant on LPP right view you will going to get, and for RPP left view you will going to get. So that is the difference between the first and third quadrant. So this completes your the projection. At the end you have to name the side view. It's a right side view on RPP you will going to get. So this is third quadrant. That means, so total around 6 exercises, important exercises I have taken, wherein most of the things I will be covering it here. Okay. So coming to the next one. So the fourth one says draw all the three views of a point P lying 60 millimeter below HP and 70 millimeter in front of VP and 40 millimeter from RPP. Also state the quadrant in which it lies. So by looking at by reading it, so what you can come to conclusion, a point P is 60 millimeter below HP and 70 millimeter in front of VP. So it comes under fourth quadrant. That's why you should read after reading the question in the operation of points chapter, you should be in a position to come to a conclusion. So where the point is located, whether in first quadrant, second, third, or fourth quadrant. From this information, so I can come to conclusion that it is in the fourth quadrant. So what I can do after drawing XY line, so for the fourth quadrant, both HP and VP will come below XY line, as well as both front view and top view will come below XY line. So you can fix your VP and HP below XY line, where in the fourth quadrant both the planes will overlap with each other. After writing it, let me take the first the information whatever he has given. The point P lying 60 millimeter below HP as given. So below HP information means front view you can get, and below HP means below XY line I should write. So that means, so you take 60 millimeter below XY line like this, draw an horizontal projector line and locate one point over there and call that as the P dash. Why P dash? Because it is the front view. So this completes your front view. Next, let me read the second the sentence. The point is 70 millimeter in front of VP. In front of VP in the sense it is the top view information. In front of VP we should draw below XY line. So that means, so now you take 70 millimeter below XY line, 70 millimeter below XY line, and draw one horizontal projector line. So already P dash are marked. So you draw a vertical projector from P dash, extend it downwards. Wherever it meets the 70 millimeter line, you locate one more point over there and call that as the P. So this itself is your the top. Now both the front view and top view is completed. Now I should go for the side view. For the side view, what is the information he has given? The point is 40 millimeter from RPP. So here also the distance with respect to why always the distance with respect to RPP only is given. It's very simple because you draw XY line like this and you will start the front view and top view from left side. If the LPP distance is given, so you should start from right side here somewhere, and then LPP distance always left side you should take. That's why almost 99% of the cases, so for the side view, the distance with respect to RPP is given because easily we can draw the side view. One case I'll take, okay, wherein LPP distance is also is given. So how to draw the projection? So in this, the point is 40 millimeter from RPP it is given. So the front view and top view, this is P and P dash are fixed here. So from this PRP dash, you can take 40 millimeter right side and draw a vertical line which is perpendicular to your XY line. And this is also one more reference line similar to your XY line. We can call this as the X1, Y1 line. The intersection between your XY and X1, Y1 line, you can call this as the origin O. Now, so side view always we have to draw on the either left or right side of your front view. So this particular the portion is RPP. Okay, where we are going to draw the side view. And here where is the top view? The top view also here below XY line. That's why. So you draw a 45-degree line in this direction. Okay, so after drawing a 45-degree line, so first you consider the top view. So P is the top view. Draw a horizontal projector from P till it meets the 45-degree line. Once it meets the 45-degree line, you draw a vertical projector line like this. Okay. Now you consider the front view, that is P dash. Now you draw the horizontal projector from P dash like this. That's why arrowhead is very, very important. So where it gives the information, so from where to where you are drawing the projector line. So draw a horizontal projector from front view P dash also. So wherever the horizontal projector of your front view and vertical projector of your top view intersects, you call that as one more point and name it as P double dash. This itself is your side view. It's a fourth quadrant. It's a fourth quadrant. RPP, which you will going to get? Both first and fourth quadrant on RPP, left view only should come, as well as on LPP, right view only should come. So the point is, he has asked which the quadrant the point lies. You can write the answer at the end. The point P is in fourth quadrant. So in this 4 examples, so I have given the complete details. So how to draw the projection in all the 4 quadrants when the information is given. Okay. Now I will take one more the example. So wherein multiple the points were given in a same question. So let me take this example. So draw the projections of the following points on the same XY line, keeping convenient distances between each projector. Name the quadrant in which they lie. So here the 4 quadrants he has given: a point A, point B, point C, and point D. 4 different points were given, and the distance with respect to HP and VP for all the points he has given. So we need to draw what he is expecting from us. We need to draw the projection of all the 4 points, that is A, B, C, and D, on the same XY line by keeping a convenient distance between the point to the another point. That is what he has asked. So now you draw a common XY line first. You draw a common XY line. The XY line is common to all the 4 points. Okay, draw a common XY line. And one more thing. So whenever more than 1 point, you need to draw it on the same XY line. No need to mention the HP and VP position, because for the A, the HP and VP position will be different. For B, it is different. Here in this case, C, it is different, as well as D, it is different. So that's why only 1 point you are drawing the projection. Then only you have to show the HP and VP. So here 4 points are there. So that's why common XY line you can draw. No need to mention the where the HP come, where the HP will going to come and where VP will going to come. All those things. First you draw the XY line. First let me take up the first the point. He says point A is 30 millimeter above HP and 35 millimeter in front of VP. So once again you read it. It's above HP and in front of VP. Which quadrant it comes? It comes first quadrant. Above HP and in front of VP. So it comes first quadrant. So the point A is in first quadrant. First let me draw the projection. So above HP means it is front view information. 30 millimeter above HP. Correct? And above HP, while drawing the projection, we should draw above XY line. So let me take 30 millimeter above XY line and draw a small horizontal projector line and locate a point. We call that as the A dash because it's a front view. And the next information he has given point A, 35 millimeter in front of VP. The in front of VP, it is a top view information, and in front of VP, while drawing it should come below XY line. That's why. So you take 35 millimeter below XY line. You draw one small horizontal projector line. Already A dash you have marked. Draw a vertical projector line. till it meets this 35 millimeter the line, and call that as the one more point and call it as A, because it's a top view. So the front view and top view for the point A is completed. And which quadrant it lies? It lies in the first quadrant. Coming to the second point, point B says 30 millimeter above HP and 40 millimeter behind VP, 30 millimeter above HP and 40 millimeter behind VP. So this particular the point is situated in second quadrant. So for this, so let me start from the beginning. Point B, 35 millimeter above HP. Above HP means it is front view information, and above HP while drawing the projection we should take above XY line, correct? So you take 35 millimeter above, which that means above XY line, draw an horizontal line and mark one point, call that as the B dash, because it is front view. Next, and 40 millimeter behind VP. Behind VP means it is the top view information. While drawing the projection behind VP means we should take above XY line. That means you take 40 millimeter above XY line and draw one small horizontal line. Already you have fixed the point B dash. You extend that point vertical projector wherever it meets the horizontal projector of your 40 millimeter. You call that as the one more point, that is B, which is nothing but your the top view. Now by looking at it, so as per the information, the point B is in second quadrant. Okay, coming to the third one, the point C, 40 millimeter above HP and on VP as given. So in yesterday's class I was discussing about it. On VP, on HP I can give, for example. So in this case, on VP it is given above HP and on VP it is given. See, the point is above HP, on VP means exactly it is placed on the vertical plane. Got it? While drawing the top view, while looking from here, okay, the top view will going to get it on the, while tilting it, you will going to get it on the XY line. You're going to get it on the XY. Similarly, when the point is on HP like this, on HP, while seeing from the front view, so it will look on this XY line. So this is the only difference. So he has given a point C 40 millimeter above HP and on VP has given. So at the end we'll decide which quadrant it comes. First let me draw the projection. 40 millimeter above HP in the sense it is front view information. Above HP means while drawing above XY line you should draw. That means you take 40 millimeter above XY line and draw an horizontal projector line, locate one point, call that as the C dash, because it's a front view. Now he says point C on VP. On VP means it's a top view information. When it is placed on vertical plane, when you see from the top, so it looks on the XY line only. Okay, the top view will going to get it on the XY line only. So that's why. So you draw a vertical projector from here, from C dash till it meets the XY line. Wherever it meets the XY line, you call that as the one more point and call that as the C. So the top view you are going to get on the XY line. So now how to decide in this case? So which quadrant it lies? So whenever either the front view or top view, okay, you are getting on the XY line, okay, one particular quadrant I cannot give for that. So for example here, this is C dash, this is front view and this is top view C. Suppose if I drag this the top view above XY line, which quadrant it comes? So both front view and top view will come above XY line. So which quadrant it comes? So it may be a second quadrant. If I drag it up the top view, so it becomes second quadrant. Similarly, if I drag this top view just below the XY line, so which quadrant it comes? It comes the first quadrant. The front view above XY line and top view below XY. That's why for the point C, so it may be in first quadrant or second quadrant. This is the answer I should give. Coming to the last one, the point D. The point D, what is the information he has given? It is 35 millimeter below HP and 30 millimeter in front of VP. So which quadrant it comes? Below HP and in front of VP. It comes the fourth quadrant. So that means let me start the projection. 35 millimeter below HP. It is the below HP is the front view information. Below HP, while drawing it, it should come below XY line. That's why let me take 35 millimeter. I'll draw it below XY line. Draw an horizontal line and locate one point. Call this as the D dash. It's a front view. Next, 30 millimeter in front of VP. In front of VP will give you the top view information, and in front of VP while drawing it, you should take below XY line. So that means you take 30 millimeter below XY line and draw an horizontal projector line. Or already the D dash point you have taken, you extend this point till it meets 30 millimeter line. One more point you will going to get, you call that as the D. So this is your the top view. Now, because both front view and top view are getting below the XY line, so the point D is in fourth quadrant. Like this, even n number of the combination of HP and VP if I give. So if you analyze it properly and if you draw it, okay, then automatically any the combination is given, you could able to complete the projection. And here the common distance he has asked. That means from one projector, that is from point A to point B to point C to point D, a common distance you can take around 35 millimeter, 40 millimeter distance you can take, and you can draw it. That's all. So this how, so there's multiple points you can draw it on the same common XY line. At the end, you need to write the answer, which quadrant all these points are situated. Okay, this is one example. So one more last example. So that's what I told. LPP distance, how to take that I will teach you. And the same concept, whatever the concept which I have given. Okay, any other 2 points or 3 points together, it is given. And naming the side view, it is one and the same. Only if you understand the concept, you can draw any number of examples. Okay. Coming to the last one, the a point is 40 millimeter behind VP is asked. 20 millimeter above HP and 30 millimeter from RPP, from LPP as given. Draw its projection and name the side view. So the same concept we will use, same method we will use. So it is 40 millimeter behind VP and 20 millimeter above HP. Which quadrant it comes? Above HP, behind VP. It comes second quadrant. Correct? So let me start with the first the information. A point, correct, second quadrant. Some of you are given the answer. Good. Let me read the first the sentence. A point is 40 millimeter behind VP. Behind VP in the sense it is the top view information. Behind VP, while drawing the projection, it should come above XY line. So I'll draw a XY line. Since it is a second quadrant problem, so both HP and VP I can draw it above XY line. Okay. So I'll take 40 millimeter above XY line and draw an horizontal projector line, and I'll locate any one of the point, and that I'll call that as the A because it's a top view. So after this, after completion of the top view, let me complete the front view also here. So next information what he has given, the point is 20 millimeter above HP has given. Above HP means it's a front view information. Above HP, while drawing it, we should draw it above XY line. So that's why you take 20 millimeter above XY line and draw an horizontal projector line. And then after drawing it, already A we have fixed the top view. You draw a vertical projector from there. So wherever it cuts this, you call this intersection as the one more point and call it as A dash. So why A dash? Because it's a front view. So both front view and top view is completed. Now we'll move on to the next information, whatever he has given. So E says the point is 30 millimeter from LPP. So till the last example, we have discussed all the examples RPP because easy to draw. Always we in our book or sheet will start from the left side so that easy for us to draw the front view and top view as well as the right profile plane distance we can take and we can draw it. That's why I told most of the cases the RPP distance only will be given so that easily we can draw the side view. So in this case, given one the LPP example. So this is your the front view and top view. So you take LPP distance is given. That's why from either from A or A dash horizontally, 30 millimeter left side distance you take and draw the x1 y1 line, the reference line perpendicular to your xy line. This is your xy line, and this the intersection point, you call this as the origin O. Now once you draw this x1 y1 line, always this is the front view, either left or right side of your front view, the side view should come. So this the portion is your LPP, that is left profile plane. And after this, a way to draw 45-degree line, always the 45-degree line should be drawn wherever the top view you have drawn. So here the top view you have drawn above xy line, so this here is the top view, that's why you draw the 45-degree line in this direction. After this, let me consider the top view. So A is here, draw the horizontal projector from A top view till it meets the 45-degree line. Now you draw the vertical projector line like this. Okay. And similarly, from front view, you can consider now from A dash, you draw the horizontal projector line like this till it meets the this vertical projector of your the top view. The wherever this intersection, the intersection line of your vertical projector of your top view and horizontal projector of your front view, you call this as one more point and call this as the side view, that is A double dash. So which side view it is? It's a second quadrant problem. Okay, LPP. So we have fixed here. So on LPP, left view only should come. That's why left side view. If it is first quadrant, on LPP, right view should come. So like that. So you have to decide and you have to name the side view left side view. Okay. So this how we have to complete the projection. So wherein all the four quadrants we have discussed, and one multiple point question also discussed, and one LPP case. So there are many cases where 2 points together is given. Point A is so and so with respect to HP and VP. Point B, and draw the side view only for the point A, like that. So you can try out those examples, and whatever the PDF it is given to you or the question bank. Okay, you can try those examples. Any doubt either for today's class or any other question which you have tried you didn't get, always either in the next class also, so you can give that information so I can discuss on that. Okay, so this completes your production of the points chapter. Any doubts is there or not doubts, let me take up, you can put it in the chat box. So afterwards I'll give the introduction. Today I'll give the introduction to your production of straight line. Tomorrow I'll start the your some few examples in the straight line. So anyone, so any doubts either for today's class or entire the production of points? If you have got any doubt, so you can post it here so that I can address to it. For others also it may helpful. Somebody has given Nagadama Suresh, Nagamaresh, no doubts. What about others? Any doubts you have? Not only for today's class examples we have discussed. So whichever the example you have tried in your class while okay preparing for your midterm examinations, so you can make a note of that so that you can give it here. I can solve it. Any example. Even question bank which you have shared, it consists of 65 examples in all the chapters. You can take up randomly, you can take up any example, unless otherwise you know the concept. Even 100 examples I can explain in the class. 101 you will get a, okay, you'll stuck up in that. If you know the concept and procedure, how to draw the projection, you can draw any example which is given by us. So any doubts? Anyone, you can post it here, or any particular question you can mention the question number. Okay, I can take it out from the PDF and I can discuss that. Any doubts? Anyone? No? Okay, then no doubts. Okay, so after the class also you can try some of the examples, so, and even inform me in the next class whichever the example that you could not get it at the end. So you can inform me so that I can give the clarification as well as the procedure also. I will tell you how to complete the projection. And no doubt, whichever the question, so it is given in the end-term examination also, with that available information, you can able to complete the projection. And you should read the data, what are the data he has given. So then only you can proceed with the projection. Okay. So this completes your projection of points chapter, where we have considered all the four quadrants, even though the second and the fourth quadrant, wherein the planes will overlap as well as the views will also will overlap. Okay, so we have considered all the four quadrants. Now let me take up the projection of straight line. So can anyone tell me what is a straight line, how we can define a straight line? Can anyone give me about this? What is a straight line? How we can define a straight line? Anyone? What is a straight line? How we can define? Somebody has posted. Let me check. Combination of many points. Good. So it's a combination of points. Okay, fine. A straight line. A line is nothing but if I join any two, if the 2 points are given to you, okay. If I join any two given points, okay, you can call that as a line. This is a simple definition for a line. And coming to a straight line, a straight line is nothing but if the 2 points are given, the shortest distance between any two given points is called as the straight line. For example, 2 points were given. Okay, I can join these 2 points in a different ways. I can join it like this, and even I can join it in this fashion also. They're all called as the line only. Simply a line is defined in such a way that if you are joining any two given points in any fashion or any way, we can call it as a line. Whereas a straight line, how we have to define, the 2 points were given. Okay, we have to join these 2 points in such a way that it should be a shortest distance between the two given points. Then only we can call it as a straight line. So now let me define this straight line. The straight line is the shortest distance between any two given points is called as the straight line. For example, so 1 point, this is 1 point. I have joined these 2 points with the shortest distance. Okay. I can get the straight line. So this is nothing but my straight line. This straight line is a one-dimensional object, even though it has got something. Suppose if I take this pen as the straight line or example, so only the length I can consider here, even though it has got some thickness, so we are neglecting the thickness. That's why a straight line is a one-dimensional object. Only the length for the straight line I can specify, not the thickness of the straight line. Okay, that's why once again let me give you a straight line is the shortest distance between any two given points is called as the straight line. Hence, the projection of the straight line may be drawn by joining the respective projections of its ends. So this how we have to define the straight line. In this particular chapter, projection of straight line, a line is our object. Okay, and now onwards, only the first quadrant, the examples we'll discuss. We won't discuss the second, third, or fourth quadrants. Always the straight line is above HP and in front of VP. Always the front view should come above XY line and top view should come below XY line. And always VP should come above XY line and HP should come below XY line. Only the first quadrant we will going to discuss in this the projection of straight line example. And in the projection of straight lines, so we have to get some more information before starting the exercises. Only the basics I'll give you in this class. So next class we'll start the exercises. Okay. In straight line, the true length of the line, so we'll use, you have used it, okay, your class. A true length of the line, we will use it. A true length is now how to define the true length of the line. A true length of the line is nothing but actual length of the line is called as the true length. Okay, these are all some of the terminologies that we're going to use in the straight line. A true length is nothing but always it should come to your mind that it is the actual length of your line is called as the true length. For example, in the question, if it says the a line measures 80 millimeter, that means the actual length of the line is 80 millimeter is the thing, but that is the true length of your line. So this is one true length, and always it is represented by TL, the abbreviation. TL is nothing but true length. The true length, how to define it? It is the actual length of the line is called as the true length. Similarly, we have apparent length also. Okay, so apparent length is nothing but always apparent length will be less than the true length. Always the apparent length will be less than the true length. Your front view and top view is called as the apparent length. It is called as either front view length or top view length is nothing but your apparent length. So true length we have discussed, apparent length we have discussed. Similar to this, we have true inclinations as well as true the apparent inclinations also. The true inclination, how we can define the the inclination of the line with respect to your true length of the line is called as the true inclination. The true inclination, once again I'll repeat, the inclination of the line, that is that the line is nothing but your true length. Okay, the inclination of the line with respect to your true length, it is called as the true inclination. If it is with respect to HP, it is denoted by theta, and if it is with respect to VP, it is denoted by phi. Okay, theta is the inclination with respect to HP of the true length, and phi is the true length inclination with respect to VP. So theta and phi are nothing but the true inclination, and always the true inclination you will going to get for the true length only. And similarly, we have apparent inclinations. Okay, so similarly, how we have defined for the true inclination, apparent inclinations also defined in the same way. The inclination formed by the apparent length of the line is called as the apparent inclination. The true length, how we have defined, the inclination of the line, okay, formed by the true length of the line is called as the true inclination. Similarly, the inclination of the line formed by the apparent length of the line is called as the apparent inclination. If the apparent inclination with respect to HP, it is called as the alpha. Similarly, the apparent inclination with respect to VP, it is called as the beta. So these are all some of the representations. Okay, we have to use how many we have discussed. True length, the actual length of the line, it is represented by TL. Apparent length, it is always the less than the true length. It is your front view and top view length is the apparent length, and true inclination, which is formed by the true length with respect to HP, it is called theta, and with respect to VP, it is called phi. Apparent inclination formed by the apparent length of the line, that is with respect to HP, it is called alpha, and with respect to VP, it is called beta. So these are the only the information, the extra information that we need to okay have in this projection of straight lines. The rest of the procedure, it is orthographic projection procedure remains same in this case. And here, let me give this information also so that in the next class directly we can start the exercises. The position of the straight line with respect to the reference planes in 4 different ways I can keep the straight line in the quadrant, that is in first quadrant. The first position which I have given, so it is parallel to one or both the planes I have given. Okay, parallel to both one or both the planes is given. So if I keep the straight line in this position, assume that my floor is my HP and my wall is my VP. Now if I keep it like this, so now the line is parallel to HP as well as parallel to VP also. Got it? So how to draw the projection for this? The top view will going to get it on the HP, which is nothing but your true length, and front view also will going to get it on the VP, which is also a true length you will going to get. That means now let me give you this information. The true length of the when you will get the true length, when the line is parallel to any one of the plane, the corresponding view, whatever you are drawing it, we can call that as the true length. For example, the line is parallel to HP, the top view will going to get a true length. Similarly, a line is parallel to VP, in front view whatever you will draw, you will going to get a true length. Now, in first case, whatever I have taken parallel to one are both the reference plane. If I keep it like this, now it is parallel to HP, parallel to VP. Both front view as well as the top view, I will going to get a true length of the line. Second case, perpendicular to one of the planes, parallel to one plane and perpendicular to other plane. For example, if I keep it like this, see, if I keep it like this, now it is parallel to HP and perpendicular to VP. Correct? It is parallel to HP. That's why the top view is going to get a true length, and it is perpendicular to VP. So when I see from the front side, it look like a point. Okay. One more thing I'll add it here. When the line is perpendicular to any one of the plane, the corresponding view, whatever you will draw it, so it is called as a point view. It look like a point. If you see from here, this pen, so only this end you can see, you cannot see this end. That's why it look like a point. Similarly, and when the line is placed like this, now it is perpendicular to HP and parallel to VP. So front you will going to get a true length because it is parallel, and top view it is perpendicular, you will get a point. So this is the second the case. First case we have discussed parallel to both the planes. Second, wherein both it is parallel to HP as well as VP. The true length I will be getting in both HP and VP. Second case where it is perpendicular to one plane and parallel to other plane. So wherever it is parallel, you will going to get the true length. From whichever the plane it is perpendicular, you will going to get a point view. Next, the coming to the third case, inclined to one plane and parallel to other plane. So we have discussed apparent the length. When we will get the apparent length? So when the line is inclined to any one of the plane, the corresponding view, whatever we are going to get on that particular plane, it is called as the apparent length. For example, in this third case, inclined to one plane and parallel to other plane. I will place a line like this. Now it is parallel to VP and it is having some inclination with respect to HP. Okay. Now parallel to VP in the sense in the front view I'll get the true length, whereas in the top view I'll going to get the apparent length. So apparent length, how to get? Okay. So this is my object. So this is one end point. This is one end point. I need to draw a vertical. The shorter distance between these two is this. So always that's why the apparent length is always less than the your true length. The top view will going to get a true, the front view will going to get a true length, and top view will going to get a apparent length. So similarly, the same case I can put it here in this way. So now it is parallel to HP and it is having some inclination with respect to VP. So the top view I can get the true length, whereas in the front view I can get the apparent length. So this is your third case. So inclined to one plane and parallel to other plane. The last case, that is inclined to both the planes. So this is what we're going to discuss with a few examples also, wherein the line is inclined to both the planes. That means the line we have to keep in this way. So now it is neither parallel to VP nor parallel to HP. So it is having inclination with respect to both the planes. So even the top view also it's apparent length and front view is also apparent length. So this the case we're going to discuss in the next class, the exercises wherein the line is inclined to both the planes. Okay, next class I'll teach you how to tilt the line to get the true length. All those things in the next class we'll discuss. So all the three cases we have discussed. So I'll stop it here today. So tomorrow class I'll be taking up this inclined to both the planes examples, and few around 4-5 examples we'll discuss, and we'll try to complete a straight line this week so that I can start the preparation of the planes next the class or next week. Any doubts you have, you can Clarify with me.